do this Wednesday like usual. There's a quiz, right? Do every Wednesday night. So this week, yeah. So the homework is going to be, this is nice. This is not too bad. Not as bad as those crazy 3 equations, 3 unknowns thing. Square root of 144 is 12. We good? You can just use a calculator. So what about square root of 0.0025? Just use your calculator. I think it's 0.05, isn't it? On the calculator there. All right. Hey, what is the square root? Like if a young child asked you, like what the square root of 9 is 3, but why? Like what if the child asked you why? What would you say? What do we do when we do square roots?
3 times 3.
Yeah, 3 times 3 is 9, huh? We're saying what times itself is this thing, huh? You all know that. What is the square root of x to the 12th? So remember the question. Remember what we just agreed square roots do. They ask what times itself is this thing. So what times itself is x to the 12th? Do you remember the rules for powers? Like what is x to the second times x to the third? Remember the power rules when you're multiplying? Remember that from algebra? Maybe it'd be good if we reminded you that for a minute. What is that? What does that equal?
X to the 5th.
X to the 5th. Yeah, remember the powers add? Do you remember that? Because x squared means 2 x's, doesn't it? Isn't that what a little 2 means in the upper right-hand corner? And x cubed means 3 x's. So altogether we have 5 of them, huh? Exactly, right? Getting it? Yeah, so this answer is going to be x to the 6th. Because x to the 6th times x to the 6th powers add, go back to x to the 12th, huh? Make sense? So when you multiply same bases, powers add, don't they? Remember that rule? So vice versa, the square root's just going to cut it in half, isn't it? You get the deal? So the square root with powers, so what would be the square root of like x to the 40th? What's that going to be? X to the 20. It's just going to cut it in half, right? It cuts powers in half. So that's what a square root will do to powers. So what's the square root of 3? And they tell us use your calculator. So if you use your calculator, you guys have your calculator with you? What's the square? So you want to definitely have a calculator on the next exam that can do, just a normal scientific calculator. Because we can't use our cell phone. So square root of 3, 1.7, that's all I know. What else is it from there? 1.732. 32? Yeah, it says thousands. So that'd be the third place, thousands place. Remember how the numbers go? Tenths, hundreds, thousands. 1.732. What was the next digit after that?
0.
Okay, so then it's rounded correctly, yeah. We good? How about the next one? Square root of 360. Actually, we can do that one, huh? Isn't that just 60? Oh, it's not 60. 60 times 60 would be 36 with 2 zeros. Yeah, I'm wrong. So anyway, so what is it? I have no idea. Square root of 360? It's somewhere between 10 and 20. 16, 17, 16 point something. I'm betting. So we have it? 16 point. Come on, help me out here. I'm doing half the problem. 16 point what?
18.97.
Oh, it's 18? Oh, so much for my ability. All right. 18.9. Give me 2 more places. 18.97. 36. Now we're supposed to round. We're supposed to round to the thousand. That means third place, right? Tenths, hundreds, thousands. So remember how rounding works? So you circle the third place, and you look 1 to the right. If the 1 to the right is 5 or more, you go up. So 18.974. That good? Rounded to 3 places. All is well. Questions on that one? 1/8. So here, let's talk about it. So when I do square root of, let's go back to square root of something like 9 again, which is 3. There's really a number understood to be in that hook. What number? There's a number really right there. Even though there's no number, there's an understood number.
2,
3, 4, 5. Okay, think about the name. What's it called? It's called a what?
2.
Square root. Now, why are we saying square? Where's the square? What does square mean? Why do we say square? What's this called? X2'd? No, we call that x squared. So what's square mean? 2. What do you say for third? What's the shortcut word for 3? Cube, right? So when we call this a square root, you ever thought about this? You ever stayed up late at night and go, hey, they're calling that a square root. There must be a 2 somewhere. Is that what you do late at night? No, this is what weird math teachers do, I know. But that's right, isn't it? Square root. We've been saying it all along. 2 root, right? So that's a 2 root. Now where's the 2? Why do we do 2? What's with the 2 thing? You get it? Where's the 2? Well, how did I do 2? 2 what? Because it multiplies twice, right? 3 times 3 twice. Okay, good. So you're with me. Now, with that all clear, what's going to happen? So if you put no number in the hook there, you mean 2, right? It's actually called the index, whatever. So what are you going to do if you do cube root? Now, what do you think that means? Yeah, what multiplied 3 times, huh? So what number times itself 3 times, cube root, is going to be 8? 2, yeah, because 2 times 2 is 4 times 2 is 8, right? 2 times 2 times 2 is 8. You've got it. So come on back here, cube root of 1/8. So now, when you got a fraction, you just do the top and the bottom separately. So the cube root of 1, what times itself 3 times is 1? Just 1, right? 1 times 1 times 1, as many times as you want is 1. And oh yeah, you're saying the whole answer is half. You're totally right. Yeah, the bottom's 2, right? Good. How about the next one? Down here, number 7. Cube root of x to the 6th. Think, what times itself 3 times? Remember, powers add. And when you multiply, powers add. What times itself 3 times, cube root, is going to be x to the 6th? 2. Going to be x to the 2nd, huh? Like that. We good? Because x to the 2nd times x to the 2nd times x to the 2nd is x to the 6th. Add them up. Is that good? All is well? All right. Says negative, well, that'll just be negative whatever. And 4096, it's the 4th root of 4096. Now, here we do 5th root. How are you going to do that? I'll give you 2 ways. You can do whatever you prefer. You can just guess. And that, I'm not kidding. I mean, you can take your with your calculator and check it out. So take your calculator, take the number, whatever, like 10. How about we start with 10? I go 10 times 10 times 10 times 10. 4 times, right? Supposed to be something 4 times. Try 10, 10, 10, 10. Hit equals. I think it's too big, isn't it? What would that be? 10,000. That's too big. So you go, oh, okay, 10's too big. How about I go down to like 8? And they go 8 times 8 times 8 times 8. 4 times. Hit equals. If that's too big, go smaller. Is that it? Oh, it's 8. I'm a good guesser. That's 8. And then don't forget about the negative in front. We're done. See, that's pretty quick. You guys thought I was kidding when I said yes, huh? No, I mean, you can hone in on it pretty quick, right? If you're too small, go higher. It's like warmer, colder. Playing warmer, colder kind of thing. Is that good? Just 8, 8, 8, 8. There it is. So just guess around. Or if you that kind of bugs you and you just want a way to go right to the answer, I'll show you how. Well, it sort of depends on your calculator. Glad to help you individually. Each calculator is a little different. But probably there's a button on your calculator. I'll say, I'll put it over here. What was it? The 4th root of 4096? It's a negative in the front. Anyway, there's probably a button. It's getting all messed up here. There's probably a button on your calculator where you go 4096 to the power of 1/4. I know it's kind of confusing. That's the way you would do it directly. You raise it to the 1 over the whatever's in the hook power. That'll do it directly, and then hit equals. And that'll give you 8. Now, you might not have that button. You might have a, like, X root button. Do you have one of those? It's just different for different calculators. If you have that, then you can just put a 4 in for this, and the 4096 there, and that'll do it directly. So, yeah, every calculator is different. I'm not going to begin to do that. So anyway, feel free to grab me if you would like to know how to do it on your particular calculator after class. I'll be glad to show you. For everybody, you can just guess. Just go higher, go smaller as needed. Does that make sense? One or the other of those methods, either to the 1 over power, or if you have that X root button, that'll do it too. Okay. Is saying 5th root of negative 1024. So use your calculator and just guess. Don't worry about the negative. Forget about the negative. Just take your calculator and say, I don't know, maybe it's 3. Go 3 times 3 times 3 times 3. Or 5 of them. Yeah, 5 of them. If that's too small, go higher. If that's too big, go smaller. You with me? Or you could do what I told you, the 1/5 power. That would go direct. Or the 5th root, if you have that x root left. Right? You all know what I mean? On that. We'll get that. Somebody got it? What is it? Is it like 4? 4. Yeah. 4. So, and it's by the way, it's negative because of the negative sign, huh? Negative 4. You guys with me on that? Negative 4 times itself 5 times. 5 negatives will come out negative. So it's right. We good there? 5 negative 4s. 5 negatives makes it right. Odd number of negatives makes negative, doesn't it? We good? All right. Let's keep it going. How about down here? 6th root of 64x to the 30th. Can you do that one? So first off, for the number, the 64, just guess. Take your calculator. Take 3 times 3 times, till you get it, or do the 1/6 power, or, however. Get the number, and then you think about what the 30th thing's going to do. Remember, powers add, right? Powers add up when the bases, same bases multiply. So what's the out front number? What number times itself 6 times is going to be 64? 2. The out front number is 2. Now, what power do we need on the x? Remember, the x powers are going to add. What added?
5.
Yeah, you just divide, don't you? You just go 30 divided by 6 is 5. Because that's what's going to happen when they add up, right? Repeated adding is multiply, so the opposite is divide. Is that good? Am I making sense in that? So 2x to the 5th times 2x to the, 6 of those would go back to this, wouldn't it? Can you picture that? Those powers, those 5s would add up, wouldn't they? All right. All right, so number 14. So cube root of negative 27x to the 6y. Can you do that one? So do the number first. Just guess on your calculator if you want. Did yellow and blue test make it around? Anybody get those? Extras in there? Do anybody still need those? For yellow and blue? So much people do, huh? So me, I just said you can pass them up to the left when you're done with them there. All right, so as we do that, so what number times itself 3 times is negative 27? Negative 3, right? Because negative 3 times negative 3 times negative 3 would be negative 27. Right? 3 negatives makes negative. Good so far. What about the powers? They add. So what power added 3 times will be x to the 6th? x2 and y4 to be y to the 12th. Good? We good? You like these? Not too bad, right? Most people find square roots not too bad. Good, okay. So I'm going to skip 15. 15 is the same thing. We're saying find g of 5. So here, let me just rewrite. There's too much mess there. So g of x is, what is it? The cube root of x minus 13. And they want me to do g of 5. Okay. So g of 5. Okay, they're bringing function notation into roots. So you know how it works, right? Whenever they give you a function and they show a number being plugged into it, remember how that works? You just plug in to the x spot, right? In a function, the x is like the holes in a toaster. It's just holding the spot where you plug in the number. You tracking with me? So just plug it in right there. So it's the cube root of 5 minus 13, which is the cube root of minus 8. And what's that? Negative 2. Everybody good there? You okay with that function notation? Just means plug into the x slot, doesn't it? All right. Section y equals square root of x. It starts here and goes off to the right. Didn't we have one of those? Right? That was that last section right on the exam. Anyway, and then what happens? Well, first off, what's the domain? If you guys used to the word domain, I can't remember. Have we talked about domain in here? I forget. Domain, what domain is, let me write it better there. Domain is the left to right, that's a bad arrow there, is left edge, right edge, left edge, right edge, width coverage. It's the width coverage of the graph. The left edge to the right edge of the graph. So for that one, the domain would be, remember you put a bracket, 0, it started at 0, and it would go to infinity. That would be the domain for that graph. Now, that's not the question. Let me go back to the question. It's that one. I'll alter it in a minute. But let me just start with the basic square root and the basic idea of domain. So we good so far? Domain is the width of the graph. How far left, how far right does the graph go? So bracket at 0, because we're right on 0 to infinity. That'd be the domain. And square root just starts at the origin. Now, remember when you start putting in numbers, it moves the thing around? So like, what if we come in here and say, okay, square root of x, I think they put a minus 5. Is that what it was? Yeah, on number 20. So question 20, they put a minus 5. What does that minus 5 do? Is that up 5, down 5, right 5, left 5? It's going to grab the center, the origin, like a handle, and it's going to move the graph somewhere. Where? Down 5. Yeah. Remember when it's outside of x's world, it's not a sideways thing, it's an up-down thing. Remember me talking about that? Remember, it's like the old saying, you got to walk in somebody's shoes to know how they feel. That's kind of like what it is with x. Meaning if it was like this, like that, then that would be right-left, wouldn't it? That would actually be x's opposite, so that'd be right 5. Do you remember all that? Remember all that move them around thing? Let me say it one more time. So if it's in the function with x, in the square root, or in the, I think we had absolute value, didn't we? Or parentheses squared. If it's in the whatever with x, then it's an x, which means it's right-left. The x-axis goes right-left. Remember on the graph? The x-axis is right-left. The y-axis is up-down. You know that. So if it's in there with x, it's going to be a right-left kind of thing. If it's not in x's world, if it's not walking in his shoes, if it's like that, which this one is, then it's not x. He's not in there with x. He's outside of x's world. So he's not x, he's y. He's up, down. Is that good, that distinction? That making sense? And the other thing you got to keep straight is x always does the opposite of what you would naturally think. Y does what normal. Y is normal. X is opposite. So anyway, this is a y effector. I call it. So y effector is going to have an up-down kind of effect because it's not in there with x. So that's going to be a down 5. That's correct. It's down 5. So what that means is you take the normal graph, which is normally right there at the origin, and you go down 1, 2, 3, 4, 5. Boom. There it is. There's the new graph. That makes sense? Just moves the starting point down 5. Down to negative 5. What's the domain? They're asking me for the domain. What's the domain? Same thing as the last one, huh? The sideways hasn't moved at all, right? The domain is going to be 0 to infinity. Right? The domain. Right? The left edge is still the same. The right edge is still the same. It's only moved up and down. We good there? On that one? So let's go back. So identify the domain. Yeah, so the domain they're going to want 0 to infinity, and the graph is, which one, A, B, C, or D? D it is. Good on that? Okay, so, excuse me. So x minus 4. So is that 4, is that going to be an x effector? Is that going to be have a sideways effect on the graph or an up-down effect? Sideways, huh? That's going to have a sideways effect, yeah. Because, let me make it a little bigger here. Because he got in X's world. He's walking in his shoes. He's in X's world. So that's going to be sideways, okay? And remember, the other thing to remember is X is always opposite. So it's either going to be right or left. Normally, you would think negative, isn't that left? That would be normally right. Anyway. So it's going to go right, right? It's going to go right 4. It's going to do the opposite. So that's actually going to be right 4. Good. So first out, which graph is it? A, B, C, or D? Oh, a couple of them look the same. Yeah, so basically it's going to go 1, 2, 3. Normally it's at the origin. It's going to go 4 to the right and go like that. So it could be B or D. B or C. B and C both look sort of right. How do I know which one? Well, I'm going to have to find some values. That's why they're giving me the table. So, let's do the domain first. There's a lot of parts to this question. What's the domain? Remember what domain is? Left edge, right edge. So what's the left edge of this graph? Where does he start? 4, right? 4. So right here, 4, right? The domain, this graph starts at 4 and goes forever right, doesn't it? From 4 to infinity. Domain would be 4 to infinity. Left edge, right edge. You with me? Does that make sense? Now, let's do the table thing. With the table, they just want you to plug in X values. So plug in 4. Square root of 4 minus 4. Square root of 0, 0. Next one. Plug in 5. Square root of 5 minus 4. Square root of 1, 1. Are you going too quick? That good? Next one. Square root of 13 minus 4, which is square root of 9, which is 3. Last one, square root of 20 minus 4, square root of 16, which is 4. So I found some x, y. Those dots, each of those two numbers, x, y, x, y, x, y, x, y, has to make a dot on the graph, huh? So the real graph will have those dots. You know what I suggest? Here, I shouldn't have erased all that. What I suggest, it's either B or C. I really can't tell which one. I'm going to blow them up one at a time, make them bigger, and look close to see which of those has these points, like 5, 1 on them. Here we go. Ready? Do you see the 5, 1's not on? Where would 5, 1 be? These are going up by 2's also, aren't they? 10, 12, 14. So 5, 1 would be right here and only up a little bit, right there. There would be 5, 1. Halfway. It's not there. It's not B. Let's look at C and we'll see. So here's the normal root. The normal root goes like that. I call it a firework. Looks like a firework, right? Because it's kind of like you set it on the ground, it sits, and shoots off to the right. But the cube root is a snake. It snakes on through like that. So it'd be good to have those on your 3x5 card for the next exam in a few weeks. So therefore now, on this question, number 22, they're doing cube root of x minus 2. So once you know the basic graph, what's that minus 2 going to do? So we know the cube root of x is basically going to be some kind of a snake. You can see all the answers are snakes. What's that minus 2 going to do? What is that in x's world?
No.
No, he's not in the root. So he's not a sideways effect, is he? He's an up-down effect. So what is that minus 2 going to do? Down 2. Does everybody see that? It's going to take the origin right here and go down to right there. There's the snake graph. So which one does that? Looks like D, right? See how the center is down 2? B and C are crazy. They're going sideways. That's not right. And so we got it. And they want the domain? Yeah, they want the domain. What's the domain? Remember domain? Domain is how far left, how far right. Yeah, negative infinity to infinity. There's the domain. Forever left and right, huh? Are we good on that? That plus 1, make it a little bigger here. Cube root of x plus 1. What's that plus 1? Is that 1 a sideways effector or an up-down? Sideways, because he's got in there with x in x's world. He's an x effector. He's a sideways effector. So, okay, so that plus 1 then is either going to be right or left. Which one is he? X does opposite. That's the other thing you got to keep straight. Yeah, so it's going to actually be left 1, isn't it? X is opposite of what you would normally think. So left 1, which of these graphs, if the normal snake graph is like that, then moved left 1. Oh, wait a minute. I didn't tell you. Okay. Wait, was this cube root? Oh. All right. I did 22 wrong. It's because of my cold, I'm sure. Otherwise, I would have been thinking perfectly clearly. I gave you the wrong information. The answer was not D on the last one. It was close, but it's wrong. Yeah, cube root. Yeah, let me get it straight. Sorry. This is garbage right here. The cube root graph actually does go sideways. Sorry. It's a sideways snake. It's a sideways snake. So, going back to it, it is either B or C. B or C is the right answer, not an up-down snake. Now, all the rest of the stuff was still true. It's been moved down too. But it's a sideways snake. So back to 22. It's a sideways snake moved down to. So which one of those is a sideways snake moved down to? C. Everything else was right. The domain is correct. Yeah, sorry. It's a sideways snake. The cube root. It's the third power that does the up-down snake. Anyway, you don't care. So let's look at 23 then. Where's 23? There it is. Now look at 23. So now we know that this is supposed to be left 1. So the sideways snake moved left 1. So we're looking for that kind of graph, right? Left 1, back here at negative 1. So which one is the sideways snake moved left 1? Yeah, it looks like A. It's kind of hard to tell. You could blow them up. It's A. And what's the domain? Negative infinity, positive infinity, right? Left edge, right edge, forever. We good? Now I got it.